Okay. Okay. So I think this I already explained, right? So does it make
Yes.
sense so far?
Yes, yes.
Okay. So let me talk about the difficulty that arise from object occlusion. So what you mentioned is actually quite correct. So an object being obstructed from view can make it more difficult and not possible to properly track. So not really to track, but to actually recognize. So if you only see part of the object and the other part is really hidden, so you are not able to really identify, right? So you cannot tell, for example, if you're seeing part of a human, maybe you're only seeing a close, but you're not really able to recognize a hand or leg or something. So you're not able to know this is a human or not. Okay, so this is an example, and this is actually, uh, to be frank, I have used some vision systems in even the industry, in real industry, and the features that actually can do this part, or how to say, half recognition. So you give it part of an object and it try to recognize it. They make it with a very high price, and not every camera is equipped with that. So that is actually something that is not so easy to do. It's always have been challenging. So and another thing, in a robot. So when I was dealing with cameras in reality in the industry, I was dealing with 2D cameras. In your case, um, as a rescue robot, you're dealing with cameras that actually need to build a 3D, to reconstruct a 3D shapes for every object it sees. And when you have object occlusion, so you have actually a problem with creating the constructing the 3D and even knowing the depths of the object that you are dealing with, due to the occlusion of the object. Does this make sense to you?
Yes.
Okay. So actually, you don't need really more cameras. Okay, you don't really need more cameras. It could be a proper way that you actually have uh, different pictures for the same object from different angles. Okay, that could be one of the ways. Okay, so now define the term sensor fusion models. Okay, your answer is okay, but you have to also understand one thing, that when we talk about a fusion, so you want to improve the data analysis, and so not only the uncertainty, but I would say uh, improving data analysis is actually important, and I would say data accuracy. What else? What else? What else? Let me see. Let me see here. Yeah. So yeah, I think yeah, improve data analysis and accuracy. This could be the ideal answer. So now, what is one of the potential challenges in rescue? Difficulty in mapping. This is correct. And what is the one potential benefit of using edge computing? So what is edge computing? Are you able to define it? Leo?
Yes.
Do you know what is edge computing?
Yes.
Okay, so are you able to share something with me?
Okay, so
So if you continue and become a programmer, I understand that the work environment in general does not really appreciate, not all the work environment. If you work with Europeans, I would say if you say I don't know, it's actually appreciated. But in the Malaysian work environment, that is not a perfect place. So you typically have to find a way to say I don't know, but indirectly. And I understand this. This is due to the environment and to many factors around you. So and I will not correct you here because I think you know the environment better than me. You take it from the ground up. So here. Just remember, a Malaysian work environment, they will not appreciate that you say no, but the European and US environment is tricky. A lot of politics there, but Europeans in general, especially Germans, they appreciate yes, clear no. Okay, now back to here. So I would say, let me look, yeah, the mouse here. So edge computing, it means that you are bringing the processing of the data on the chip or on the computer that is loaded on the robot. So you have I would say something called cloud computing. Do you know what I mean, cloud computing?
Yes, I do.
Okay, so you know that cloud computing is a computing or computing power that is done remotely. So it is
Yes.
it could be a server that is located somewhere, US, Europe, whatever. Okay, and we are sending the data to be processed there, and we get the results sent to us. So this can be only done through a network. So if we are inside a building and the network communication is not there with the robot, so that could be a problem. So we need to equip the robot with edge computing, which means that it needs to be able to process the sensor data and other real-time processing abilities on board. So we need to equip it with real-time processing power. That is called edge computing. So it will help, how to say, if this is a cloud, it means that we will do a lot of initial processing on the robot only when we have no way to process the data on top of the robot itself. So we can send it to the cloud for processing, because typically the cloud have higher abilities and high computing power. We are not able to equip the robot with high computing power same like the cloud, and we are not able to put RAM same like the cloud. Definitely, you will have a small board that is able to control the robot. So typically, it will not have RAM same like a server in the cloud. Does this make sense to you?
Yes.
Okay, so now, so your answer is, let me see actually what is our choices here. Okay, the potential benefit actually is not improved mobility for rescue robots, but actually it's better communication between robots and humans. So let me try to actually explain that. Let me see here so that I'm able to explain it in details. Okay. So improved mobility for a rescue robot. The mobility is actually how to say is told by the robot design and actuators, and not necessarily where the data processing happen. Okay, so let me go one by one actually. So the choices that you have is a preparation for entering a disaster zone. So edge computing does not really directly impact the pre-deployment preparation. So if we talk about the second choice, which is improved accuracy of robot sensors, um, so while edge computing can actually enable the on-device processing, but improving sensor interpretation wouldn't really directly enhance the sensors themselves, or I would say the accuracy of the sensor that does not really impact anything on the edge computing. Edge computing, which is means that you equip the robot with more processing power, and sensor accuracy does not really play a part here. So it remains the remaining things that actually uh, it's the best choice here, which is better communication between the robot and human. So the thing here that you should talk about a few factors. We should talk about reduced latency. Okay, so it means that if you are sending the data to cloud computing, that will take time because it's done through a network, and then also communication and network availability inside the building might not be perfect. So that will introduce latency, means that there will be delays. So typically, rescue robots sometimes need to inform the human that is controlling the robot with information. So that information will see a delay, or we'll see latency if you depend on network communication. Okay, so also if you use edge computing, means that your processor on the robot itself process the data and does need a network, so you have a bandwidth efficiency actually. So you improve the utilization of the bandwidth. Okay, you know what's the meaning of bandwidth, right?
Yes.
Okay. And also, when you take a decision on board, it means that the computer on top of the robot are able to actually take a decision far away from the interaction of cloud computing. It processes the data on site inside the processor that is equipped on top or loaded on top of the robot. It means that um, it will take a real-time decision, that there will be a lot of analysis that can be done on board, rather than just depending on the network and the cloud computing. And then if this network communication is stopped, then you will find that the robot acts like a dump. He cannot take a real decision. Does this make sense so far to you?
Yeah.
Okay, so yeah, okay. Can you continue the remaining of the questions?
But the other ones aren't paper 3 questions, but do I just answer them anyway?
Yeah, definitely.
Okay.
This is an excellent answer. But what is other options? Do you know any other options that you can? So this is one of the solutions, yes, and which is the easiest. Okay, I can understand you are the smart guy, but what else you can see from that? Uh, Another solution for that? So from the truth table, you see that there is 2 zeros that result in 1, and 2 ones that result in an output 1, right?
Yes.
Okay. What this can tell you? And actually tell me, how do you think? So how you reach an answer or a conclusion if you see a truth table? Because there is high probability that you actually given 3 inputs, not a simple one like that. But okay, let us discuss how you actually think about it. So this isn't it? This two inputs. The first one in the truth table, and the last one, is it contradicting?
Which ones?
So the 2 zeros that result in 1, and the 2
Yes.
ones that result in 1, is it opposite to each other?
Not exactly, because both of them are ones. So both of them are situations where the two Boolean values are like the same. So
Okay.
in that, yeah.
So good. Okay. So now tell me now, if I'm having different output. So if I look at the last ones that result in the 2 ones that result in Z output equal 1, I would say simply go for an and logic gate. Okay, and if I look at the first part of the truth table, I will also think about and, but equipped with not.
Yep.
But then, and my question to you now, if I would like to draw a circuit like that, how can I group those 2 different possibilities? The and with a not and the normal and, to actually come up with to draw a circuit that have maybe 2 levels. So in short, just this is something that A and B, A and B. Okay. Now, what can I draw here to actually complete the circuit? So this is equipped with not. Am I drawing it correct?
Yes.
Okay. So now, how to do that?
Okay. So the ones on the bottom would also have A and B as inputs.
Yes, definitely. Yes, definitely. So what we do is something like that, or no, sorry. We have to jump here, and definitely that have to find a way to connect that to B. Yes. So this could be the way that you can draw the ends. Okay. Of course, it's not so perfect due to my drawing, but this, in conclusion, this this is what how it should look like. Okay, but then so I would say if
what you could do is,
yeah.
yeah. So what I uh what I was thinking was uh actually never mind. Just a second. Okay, never mind.
Okay, so I would say if you have different outputs that you want to actually represent. So now you have two zeros that produce one and two ones that produce actually one. So I would say yes, actually what you are thinking here is correct, because you should actually write a logic expression before you start to do that. But in short, this should be OR. So your OR, the OR is always the one that collects different inputs for you.
Oh yeah.
So did you get what I'm trying to tell you?
Yes, yes.
So okay. So this is not only for this answer. What you answered here is perfect, but I'm just I want to show make sure that you already think in the correct way. Okay.
Yes.
Okay. So can you look at the next one? Yes, physical installation like CD-ROM, DVD-ROM, or even memory stick. And I would say also here, um, adding new features. They are able to add the fix bugs, they improve, they actually close security holes, close security, sorry, Sec oops, security holes. Okay, and also add features, add new features. Okay, and what else? Yeah. So what other questions we still have? Am I able to actually hear the way that you trying to tackle the problem?
Okay. Well, so first of all, how this algorithm seems to work is that it takes the number input, and if it's divisible by both 2 and 3, then it is output.
Okay, good. So which numbers can be divided by 2 and 3?
So out of these, those would be 6, 12, and 18.
Again, sorry, can you tell me?
6, 12, and 18.
Perfect, perfect answer. Move to the next, please.
The binary tree one, I'd have to draw it. So could I just move on to the one after that?
Yeah, sure. So what is remaining then?
Well, out of those slides, we've already gone through the other ones, but the paper 2 PDF, there's still questions left on there.
So yes, please have a look at that question, and I will tell you the selective things that we need to look at. We will not look at all of them. Just open the slide, please, and then I will also open it with you here, and let us together have a look. Yep. So you already open it.
Yes.
Okay. Can I understand from you how you start actually reading the question? You read from the text. I mean, you start reading from the first page text, or you go down to the questions first and read the questions.
So generally, how my process is, well, first of all, I just read the description of the code itself. And then I read the question, and then I go over to the code, depending on which parts I need to read through.
Okay. So I will send you, I think part of this PDF file, unfortunately, was not printed properly. So I will send you only the questions that we actually need. Because there is 3 portions that have 3 different classes. So which did you check, or did you have a look at the first class? At the first page, you see a class, right?
Yes.
So this is the points class. Okay. If you read the text above the points class, that will give you an indication what this point class do.
Yep.
Okay. Did you understand now?
Yes.
Okay. Can you first have a look at all the private variables? Do we have to close and open again?
Okay.